Hello. This is a response to Sabine Hassenfelder's video about the speed of light. And it's my opinion that it probably can't be broken. But, first I'll address her complaints about her career. Try being me. Nobody believes me. They don't believe anything I say. And my experiments are simple and repeatable. They still don't. And, other people, they take a loop of wire, a magnet, and 2 spark plugs, and they tell you that you can light a light bulb with it, and they get 40 million views. I get 40 views. So, anyway, this is my first response video. And let me first start by talking about what I know about fields. Now, this is not what other people know about fields. They know a lot about fields that I don't. But this is what I know. Now, here's a magnet. It's got a field around it. If I put it in my pocket and walk around all day, the field follows it around. This is the cause of this particular magnetic field. I'm not going to say that it's detached from the universe after I just did. I won't tell you, you gotta watch my video. But admittedly, there are some things I don't know about fields. In fact, I just proved the existence of Santa Claus with my last video. But that's the magnetic field. Now, let me take another field, an electric field. This field, well, the magnetic field has lines that go around and attach to itself, and you can detect it from out here and all that stuff. Oh, I'm talking about the electric field, though. The electric field, the lines go straight off forever, presumably. And again, I move the battery, it moves the field. The electric field is situated differently as I resituate the battery. Now, let me talk about gravity. There's another field. I feel it right now. I feel something pushing me up. I think it's the Earth. So, again, gravity is usually caused by large masses. We know this. So, the mass goes somewhere else, the gravity follows it. When we look at things, we're seeing their fields as they were the speed of light away from us. We are seeing them as they were and not as they are. And there's a discrepancy between where they are and where we see them because of the speed of light. So we all know this. Sabine's concern about breaking the speed of light has to do with the energy required. Well, I might have that one licked, because when you accelerate a particle, they say it gains mass. Well, so you need to keep pouring more and more energy in it because you got to move all that extra mass. Well, what if we accelerate something to very nearly the speed of light? But we do it pointed at a source of gravity, like something big like the sun. Well, that's kind of inconvenient. Okay, Jupiter. Now, gravity doesn't care how heavy it is. The heavier the better. In fact, since it's m1 times m2 over r, as m1 gets bigger, it's going to be a greater influence on m2. And the better the party. Like I say, it doesn't care how much mass it is. It all falls at the same speed. Even better, because it compounds. So energy might not be such a problem, but let's go back to what I know about fields again. Now, let's say I'm on that rocket ship, and I'm going very nearly the speed of light. Well, everything is fine. I don't know that. I don't know I'm going. Velocity is totally relative. And so in front of me, waves are bunched up. But I don't know that because I'm bunched up too. In back of me, according to another observer who thinks I'm going very fast, the waves are very spread out. But I don't know that because my ruler's longer in that direction. Not in this direction, only in that direction. This is Lorentz contraction in the direction of travel only. So then, here's the problem. I get to the speed of light. Or let's say half a mile an hour over the speed of light. Okay, now my world is different. I look this way, or that is, the field is no longer attached to the matter that caused the field. So now my universe is different. We have a problem here. And at the very least, we have a shock wave that would be high powered, because we have a discrepancy between the location of a field and the thing that caused the field. And now causality becomes a problem. Now, add to that some of the components of the matter are themselves only energy. Well, they go at the speed of light. Now you've got this thing trying to go faster than the speed of light, and part of it's made of light. So I say it's a hard speed limit, and it can never be broken and will never be broken. Now, back to your career, Sabine. I wish you'd look at my videos because you are not afraid to voice an opinion. And you are out in front. You're not doing physotainment. You're on the forefront of what's happening out there. And you're only missing one thing in your career. And that is to help me with some of my experiments. I have a BBO crystal that is Brewster cut, and I have a 310 nanometer laser because I would like the results to be visible to make the experiment easier. And that's all I need to tell you, because I guess you know the rest. So I wish you would consider that. It would do a lot for your career. I'm not saying it would advance your career. You might get like me, where you get like 600 hits.